Start recording. And let me share my screen. Okay, see. Okay, can you guys see my slides?
Yep.
Yeah.
Okay.
Yeah.
We have a few more joined. I think Chris. Okay. Some people not from TAF, so. Hello. Yeah, I don't know what happened to the wrong link, but now I'm glad you are here. Okay.
Yeah, and I'm going to message as well the rest of the team. Like I flooded my community with the link, with the previous
Okay.
link, so I have to message them there. Okay.
Okay. Sorry about that. Okay. All right. Let's get started. Hi everyone. I think I'm really glad so many people are interested in learning about script. I mean, it's in the broad sense how to do smart contract on top of Bitcoin. So I'm just going to cover a few things today, all at introduction level. So I want to make this also interactive. So if you have any questions, just feel free to interrupt me anytime. I'm happy to answer them. So just a few things. First, I'm going to talk about, what do I mean by smart contract on Bitcoin? And then I'm going to talk about, usually when people heard about this term, they think about other blockchains. So I'm going to, explain why do we want to do smart contract on Bitcoin? Actually, I would argue is the best, blockchain out there to support smart contract. And then I give out a few, I think the most interesting use cases so far people have designed, and hopefully to, encourage you guys to explore more. I think if we can make this a recurring, and then we can dive into detail. But today, I just want to, hopefully get you excited about what we are doing here. So you all started with, we talk about Bitcoin's SV, Satoshi vision. So why do you want to, do smart contracts on top of Bitcoin? Because most other people, they think about, Ethereum, Solana, Tron, whatnot. They don't usually associate smart contract with Bitcoin, but they always started with the original vision. When Satoshi released this Bitcoin, in 2009, actually the first version, 0.1, it comes already with the capability to do smart contract. For example, even Satoshi mentioned this kind of explicitly on the Bitcoin forum, talk forum, says, if it'll be great if you can send some money send some cash, digital cash from Alice to Bob, but that's not the only. It's just one thing about the hello world of what Bitcoin can do. It's actually much more. For example, he said you can do like arbitration, multi-sig. Basically he designed it in a way such that all those use cases later on, they can be added into Bitcoin on top of Bitcoin without changing the underlying protocol, which is we mean by setting in stone, right? So the way he designed this is to, in today's kind of a computer science term, he built a virtual machine inside the Bitcoin. Okay, so what does that mean in specifically in the Bitcoin model? You probably heard about, if you are in the Bitcoin space a little bit, you probably heard about this term UTXO. Basically means, unspent transaction output. So think about when you talk about Bitcoin, it's uses the so-called UTXO model. It's almost like a cache. So you have all kind of different nodes, cash, right? You have maybe you have $1, you have $2, you have $5, you have $10, right? So you have different denominations. So those are not, when you log into a wallet, you see a whole balance, but that's not how actually it's stored in the blockchain. In the blockchain, all your nodes, all your cash, all your Bitcoins, they're stored in the outputs of certain transactions. You probably heard about the Bitcoin transactions, right? So that's how you spend your Bitcoins, you by broadcasting transaction to the miners, when the miners then process it. So for example, in the slides here, I have two transactions, this is the input and this is the output. So in the UTXO model, how does this work? Because you need some mechanism, right, to prove you own this Bitcoins, because otherwise, anybody can spend any of the Bitcoin, the whole system will break down, right? So you need some kind of like authorization here. So this is what the Bitcoin smart contract comes into play. And this links back to what I just said. So think about every output that has not been spent yet. There's a lock on top of it, locks it. And only the one who can produce a valid key, you can unlock this in the input, and then you can move the Bitcoins. Think about this a way to prove you are authorized to move the Bitcoin here. And the way, this is designed is this lock, usually when Alice sends some Bitcoin to Bob, this lock basically says, if you know about the private key, public key basically means here, there's a public key here, or address, the so-called Bitcoin address is equivalent to a Bitcoin public key. So if you have the corresponding private key, you can unlock. But that's just one type of, the most popular type of so-called smart contract. Smart contract meaning here is, you can have arbitrary logic inside this lock to decide, okay, what kind of conditions that has to be met before you can spend the coin. And the Bitcoin virtual machine comes here because, you have a so-called kind of like a virtual machine here. It's not a physical machine, but it can take a list of instructions, which usually called the Satoshi design as called Bitcoin script. So think about it's like a assembly or even binary instructions for CPUs, right? If you think about the easiest example would be like you have an add instruction. So you can add two numbers, you have a multiplication command that can multiply things. So this is a fully functional virtual machine inside. So it basically encode a logic, the locking mechanism. Think about like a function, mathematical function. This is the function here, and this is the key, the argument into this function. So for the virtual machine, it just does, so it has a function, and then once you have the input, it will compute. And then it will only give you two results. So that's why it's also called a predicate. Basically, think about it as a mathematical function that returns only true or false. So the Bitcoins can be moved only if this function returns true. So this is the function plus the arguments here, the input here is what we call, smart contract in Bitcoin space. Okay, I'm thinking that's probably a lot of information I've just dumped if you have never heard about this before. So I'm just pause a little bit to see if anybody has, questions or comments. Anyone?
No, makes sense.
Okay. Anybody else? Okay, so we got a very smart audience, so I'm glad. I'm going to move on, but you can talk with me anytime. So now we talk about at the highest level, what is a smart contract on top of Bitcoin? That basically means, the normal Bitcoin transfers we are doing is pretty much like the simple, like a hello world of the Bitcoin smart contract, right? So you can basically, this function here says you need to prove you have the private key, you need the signature that corresponding to the public key here. Once you have this, it's going to return true. Otherwise, you will return false and you are not able to move the Bitcoin locked here. So another big, before I dive into detail, another big, I would say misconception out there. I would just want to get it out of the way. I think this is, if there's only one message you get out of the whole talk, just this slide. So, because most other people, especially even in the Bitcoin space, I'm not even talking about the general so-called blockchain space. I think, hey, of course, okay, you now kind of convinced me, Bitcoin, they have the Bitcoin script that's embedded into the original client by Satoshi himself. I kind of get that, and also it has some instructions, but it's very primitive. They say, oh, it's not Turing complete, which I'm saying here is actually to the opposite. Not only is Bitcoin not primitive, it is the most powerful smart contract platform out there. What do I mean? Basically means it's Turing complete. So by Turing complete, in layman's term, what does that mean? It's basically whatever smart contract that can be implemented on other blockchains or run on any computers. For example, your desktop, or even by 10,000 servers in some data centers, or run by the AWS, whatnot. If any program that can be run by any computer out there, you can run it on Bitcoin. I'm not talking about efficiency, I'm not talking about the cost. Just get that out of the way. So basically, whatever program you can code on other blockchains or on any machines, computers out there, you can code it and run it on top of Bitcoin. So it's fully programmable, and it's the ultimately programmable machine out there. So here I'm showing the one for people who've heard about this term, basically Turing machine. So Turing complete basically means you can run, if a system is Turing complete, that means you can run any Turing machines. So here because I want to prove this, so I just you probably heard about Craig and some other people that publish papers, academic papers, which I strongly recommend to check out. But here I just want to that's the theory side of things. For me, I'm always want to get a kind of like experimental side of things. So I actually implement some Turing machines on top of Bitcoin. For example, in here, this is a Turing machine. You can see it's working. Basically what this Turing machine is, it recognizes paired parentheses. So if it's if you have left, right, if these parentheses they're fully matched, it's going to return true, and otherwise it's going to return false. So I'm not going to dive into details, but this is a Turing machine, and so this is just one example. If you can implement one Turing machine, you can implement any other Turing machine on top of Bitcoin. So just get that out of the way. Any questions here? This is probably, if you've never heard about this before, probably this is a little bit shocking. Go ahead.
I have a question. So when you told that Bitcoin smart contracts are Turing complete, did you mean BSV or both BSV and BTC?
Oh, I mean, when I talk about Bitcoin, it's always meaning the original protocol, which is followed by Bitcoin SV. So BTC actually can do pretty much nothing, because I showed the virtual machine, right? They pretty much disabled all the virtual machine instructions. So pretty much they cannot do any of these programmable things. Even we want to do it on top of it, but it's pretty much disabled. So they cannot run on this.
Okay, thanks.
Pleasure. Good question. Yeah. Anyone else? Okay. If not, I can just keep going. So go ahead.
I was just going to ask you. So all these state changes, these are, I mean, if we think about Bitcoin, are these all new transactions, or is this all happening in one transaction?
Oh, very good question. Yeah, in this case, what we have implemented is each transaction is going to be a new transition, is new Bitcoin transaction. So think about
so each time something flashes, yeah.
Yes.
Okay.
It's a new Bitcoin transaction.
Yeah. Thanks.
Yeah, but in some cases you can also, if it's bounded, you can also put in a single transaction. That's also doable. Do you see what I mean? For example, this runs like because you run it off chain, this is going to run, finish in 100 steps, right? So you just code the 100 steps in a single Bitcoin transaction. That's also doable. Yeah. But just here, I want to prove it's unbounded, because as long as you want to put money, pay the fees, you can keep this forever, right? Because a lot of people out there, they always argue with me, what do you mean by unbounded? Literally unbounded. If you pay, you play. So this transition can keep going forever, as long as you pay.
Thanks.
Okay. So once we have this high level idea, and the other reason is, okay, now you kind of convinced me a little bit, you can do smart contract, and you can do pretty much what other blockchains can do out there. But why do I even want to do, we talk about other competing blockchains, right? Ethereum, Tron, Solana, they're also very programmable, and they are claimed to be also Turing complete. But then why do I worry about the Bitcoin then? And the answer here is very easy. We talk about this term a lot, scalable. So, you know, the way I just show you in the previous 2 slides, right? One is the Bitcoin uses so-called, you know, UTXO model, right? So think about it's like physical notes, right? Bills, dollar bills. So all this $1, $2, $5, $10, if you have, let's say 10 notes, you know, each is $1. They're all pretty much independent, right? Meaning you can give 1 note to Alice, you can give the second dollar to Bill, the third to Charlie, whatnot, right? They're all independent. So what does that mean in terms of scalability of a Bitcoin smart contract? That means they can all, because they are independent, so they can all be processed in parallel, right? And it's actually maximally parallel because you can not be more parallel than that. Each smart contract instance, they can be processed by a thread, right? So in terms of implementation, they can be processed by, think about, you know, let's say you have now you have say 10 UTXOs there. You can just throw 10 machines at it. Each one process 1. And if you have 1,000, if you want to be fast, you can just throw 1,000 machines on top of it. So that's what they call the, you know, horizontally scalable. That's actually all the internet service how they scale today, right? For example, Zoom we're using right now, right? So after 2020, you know, pretty much the user number exploded, you know, exponentially, and we don't, we can still keep up, right? Zoom, and also Google Meeting, or Facebook, or Twitter, Amazon, all the biggest internet service that are serving billions of users every single day. They use this approach to scale. So basically, how do you support more users? You basically throw more machines at it. So that's how it's been proven how to scale, right? So Bitcoin also enables, because it's so-called UTXO model, so it enables this kind of, it has this kind of scalability, right? So for you know, in child, probably if you ever get your hands already on some kind of like a testing version of a Terra node, that's also how it works also. So throwing more machines, you're going to handle bigger blocks. So versus other blockchains, you know, say Ethereum, it doesn't work this way because, you know, all the smart contracts, they are not independent, they are interdependent. That means if you run this one smart contract A, it may affect smart contract B, or B may impact C. So what does that mean in reality? That means you can only process them sequentially. You finish running A, and then you can process B, and then only then you can process C. So the only way they can scale is, you know, in a machine analogy, you're buying bigger and bigger machines. And because at any given moment, there's always a higher ceiling on how powerful the one single machine can be, is actually put a bottleneck on the scalability. That's why, you know, not even in practice, in theory, so all such blockchains, you know, so-called account-based or whatnot, they cannot scale even in theory. So that's no way. That's, you know, we're also seeing this in reality, right? So when it first launched about, I think 2015 or 14, it can process like a 15 transactions per second, right? Today, even 2020, after almost 7-8 years, if you look at the main net, you can, for Ethereum, you only process about the same, 15 transactions per second. Versus us, when we first split from BTC, they can only process like 5. Right now, we can process easily 5,000, right? So, and then once we have Terra node, you can, there's no upper limit. It's just economic. Is it worthwhile to throw more machines at it? So that means it's maximally scalable, and also it's maximally programmable. So then that you back to the question that whatever other blockchain smart contract they can do, we can do it. But because we are more scalable, we can do the same thing, but then at 1,000 times cheaper, or even 1,000 times faster. Then pretty much there's no, you know, I just don't see the good argument. You know, why do you want to run on other blockchains, right? And I'll just pause a little bit here again and see if any comments, questions.
So what about new blockchains? I know that Sui is saying it's very high concurrency for processing transactions using its narwhal, whatever protocol, using a DAG. So I suppose that's something that's,
Okay.
I mean, I suppose the new generation of blockchains might be looking at that sort of thing.
Okay, yeah, very good question. So here's the thing, right? I've been in space for a while, and this is probably like 1,000th time I heard this claim, right?
Yeah,
Personally, I probably heard about, for people who stick around, you probably heard about 2017 is EOS, and then in 2019 or something is Sonata, and now it's SU or whatnot, or Near Protocol. You always have
so
this
I suppose
claim.
the Bitcoin stuff is tried and tested, isn't it, as well? It's been around for so long. It's not
Bitcoin is the only one that's been proven. For others, I haven't checked all of them because every day there's something come up. But here's the thing, right? So one is unbounded scalable. That means there's no limit, right? So if you look at other blockchains, when they say, oh, they can be paralyzed, it just maybe to some extent. And usually, even if you believe what the white paper is claiming, right? Usually they give a best scenario, right? If you remember yours, they're talking about 5,000 transactions. And then you talk about Sonata, I think they claim they can reach 50,000, right? But once you launch the mainnet, it all has all kinds of problems. But even that, given that they can reach what they claim, right? That's a big question mark. But even given them that or even Sue you talk about, they probably have some very high TPS number out there, right? I'm saying, okay, they have not launched, but I'm give them benefit of that, right? I just say assume they can reach that. But that's not enough, right? Even assume they can, let's say whatever number they throw, the 50,000, but we already can handle, at least for 10 or 50,000. As the biggest difference is the Bitcoin is the only one that's unbounded. For all others, they can say we have some huge one, right? That exceed, let's say Visa, Mastercard, whatever, 60,000 per second. But still, there's a bound. Once you hit that, then you're going to crash again, right? That's what we have been seeing on Sonata.
Yeah. So, and what about gas? So, not other blockchains, you have to pay gas so that it limits the computationally difficult, I suppose, functions. If you're going to run something that's going to take a long time, or something that's going to tie up the computers, you pay for it. Whereas in Bitcoin, you just pay the transaction fees, I imagine, yeah?
Yes. So it leads back again to scalability, right? Because if you think about scalability, it's like you have users sending transactions, and then you have miners process, or POS, the validator, whatever they call it. You basically is a two-sided market, right? So you have demand for this processing, and then you have supplier. Because of the scalability, in our case, basically unlimited block size. This because the supply is almost is unbounded. If it's the same type of computation, it's going to be much cheaper, right? So think about analogy, right? So if you have the same number of people, you want to, let's say Uber, right? If you have if you want to go to from point A to B, if you have only one car in London, it's probably going to be very expensive, right? But then you have 10,000 people driving around, it's going to be very cheap, right? And same thing here, because the supply is much bigger. The whole fee is going to be orders of magnitudes cheaper. As what we have seen here. In reality, is also when you send even, let's say, the simplest transfer, right? You send 1 Ether from Alice to Bob, it probably costs you a few bucks, right? But for us, it's a fraction of a cent.
Yeah.
So at least it's like 4 orders of difference. So you kind of have the theory scalability here, and translate it to reality. That's what we can see. You don't have to trust everything I've said here. Everything you can just send some transactions. You notice the difference. Okay. Pleasure. Any other question? Okay, if not, just keep going. So far I've talked about what it is smart contract of Bitcoin, and hopefully give you some idea why do you want to do it on Bitcoin. And then there's a little bit of theoretical. So I'm going to, for the next rest of the slides, I'm going to talk about what are the cool examples people have built, which is a lot of people think it's impossible on Bitcoin before, right? So I think one of the best example I can give, I think which I released actually yesterday. So this is the pretty cutting edge. I think this is the most advanced version out there. So basically you can outsource any kind of computation. So today, right, when you have a lot of the so-called cloud infrastructure. So you, instead of have your all the devices or computation down on site in-house, you probably run some machines out there on AWS, Google Cloud, whatnot. So you outsource this computation out there, and then you once you finish your computation, you get it back to locally to a client. So think about easiest case would be, I give 3 examples here. So for example, if you, I don't know about you, but if you're into a Sudoku, puzzle, and at some instance you can solve it easily, but sometimes you kind of feel, oh, this is hard, I don't want to solve it. What do? I just put a smart contract, by sending a Bitcoin, single Bitcoin transaction out there. It says, what's this smart contract? This logic says, if anybody who can solve this Sudoku, you are going to be paid 1 Bitcoin. So this is the only technology actually out there. I'm talking about all technology, AI, machine learning, whatever latest technology. You can do this without a trust third party. So what does this mean, right? So it's also very easy, right? So for example, you have Alice, you have Bob here. Alice wants to say to Bob, hey, if you solve this my Sudoku puzzle, I'm going to pay you 1 Bitcoin. And then Bob is concerned, right? Because if Bob just tell Alice the solution, then Alice may run away, right? But he's not getting paid. But it's also the other direction is also, that's a problem, right? If Alice pays Bob first, then Bob may run away and may not pay her, may not give her the right solution, right? So this always happens. I think this is what at the core of so-called smart contract. You basically to minimize the trust when 2 people that are doing transactions on the internet. Right? You always have this kind of fair exchange problem. If Alice give first, Bob may run away, and Bob will reveal solution first, and then Alice will run away. So using this smart contract here. So basically you can think about the Bitcoin now is almost like an escrow as a whole. But the good thing is you don't want to trust, right? Bitcoin is you send a transaction, and the only way Bob cannot cheat, Alice also cannot cheat, right? So if this so-called atomic exchange. So Bob send the transaction containing the solution, and then he can get paid because he can unlock the UTXO, the lock, right? And then once he broadcasts the transaction, Alice can see the transaction, and he can read the answer from there. So our approach here is, has never been achieved before, is only Alice, because here everything is on chain, right? And we do some kind of encryption. So basically it says the answer is encrypted, but only Alice can decrypt it. So nobody else can see. And this is the first ever such example out there. Previously, there's some examples, but everybody can see the solution, which is not ideal all the time, right? For example, you are, instead of outsourcing the Sudoku, this kind of like a trivial example, what if you apply to some real use case? For example, right? Let's say you are UPS, right? You want to find the optimal route to deliver some packages, through a neighborhood. You want to minimize the gas cost, right? So you can do it in-house, but also you can say, hey, I post a bounty. If you can, give me a route, the so-called traveling salesman. If you give me a route that can deliver all the packages with the shortest path, I'm going to pay you, let's say, 1 Bitcoin. Or if you heard about this, if you know about machine learning, there's a website called Kaggle. So basically it's a machine learning, almost like a marketplace. So if you're a real company, let's say Netflix, you want to see what's the best recommendation algorithm out there, the machine learning model, you can host this competition, and whoever give you the best one, they can be paid. Actually it can be a significant amount. I think the biggest I've ever seen is like more than $1 million. If you can think about the Kaggle or this kind of machine learning computation, but instead of it through this company, you can just you can do this on chain by sending one transaction. Hey, if you give me the best, most accurate recommendation algorithm, I'm going to pay you, 1,000 Bitcoins. So you don't have to go through this centralized service because you have fees, and then it's not transparent. You have all kinds of benefits. So, and the theory is even if you have any arbitrary computation, for here, I just give a few examples. but you may have your own computation, right? Because at the end of the day, if you think about what we're using for computers, it's all doing computation, right? So that means for pretty much all the practical use cases, if you don't, you can outsource this by just post a bounty on chain, and then nobody can see the solution other than you, and nobody can cheat. So this hopefully can, open source, open a lot of use cases out there. The way I think about it is like almost like a cloud 2.0. So right now the cloud is, you have to run the machine, you get some developers, you write the code, you run them, and you get the result back, right? But actually, you don't want all the intermediate steps. What you want is the final result, right? But if you can remove all this, the mess in between, you just broadcast some bounty, outsource it, and then the other person can get paid, you get the result immediately. You can save all the intermediate steps. I think that's, in the long term, it's going to drive down the cost of computation. And the market is more efficient, right? So you don't have to go to some big cloud provider. Remember, this is open, so anybody in the world, if he has good ideas, algorithms to solve some of the computation most efficiently, he can just get paid. So instead of have a few dominant players, anybody who can be a provider here, because if you can solve it, doesn't matter. Bitcoin, right, is open in the blockchain. Anybody can see the bounty, and then if you can solve it, he can claim the bounty. Okay. Any thoughts on this?
Yeah. What happens if two different people reach the same solution, or two different solutions that are valid? Because maybe for the logistics there are more than one route that is okay. So what happens if two or more people provide a valid solution? You need to pay them separately, or how does it work?
No, again, it's like almost like in reality, right? So the first one, because there's only one transaction out there, right? One UTXO. So whoever is going to send the solution first is going to get the solution.
Okay.
Which is also fair, right? Because if you have both of solution, whoever comes first can take the money.
Okay.
Yeah, you probably need to be very careful the way you write that contract, right? Because someone may find a solution that is, for example, if you put like an algorithm, you write that contract that whoever pass minus less than 1 second, that algorithm wins. And then someone will say time equals 0.5 and then returns that as the solution for your contract. That's what I say. You cannot verify that their solution is good, right? You just write that in the contract. The way that it's verified is through the contract itself. There is no human looking at the solution that they're providing, right?
Yeah, that's why the so-called the computation here, it needs to be something like almost like a mathematical. For example, is this solution to the Sudoku problem, or is this like shortest path? It may not answer something like let's say tomorrow. Tomorrow's weather at London at 3 p.m. is going to be raining or sunny. That's something not at least you cannot easily put in a contract, because for the contract usually is dealing with some kind of like a mathematical or cryptographic statement. For example, some X that hashes to Y, right? But you cannot know outside information. For that type of information, you need to have some kind of trust third party, like which usually we call oracles, to import external data into the blockchain. For example, Chainlink, right? That's another. That's one way to import external data into the blockchain. Is this what you are talking about here? Okay.
I understand what you mean. Yeah. You probably need additional information to make sure that your contract has been fulfilled correctly, right?
Yeah, pretty much like every other program, right? It's all the system works only if you're writing the code you're writing is correct, right? Because if you have a bug, somebody can hack it. It's like any other computer program. It's not specific to Bitcoin smart contract.
Yeah,
Okay.
I have a question as well.
Go ahead.
Yeah, I'm thinking about the analogy of Alice and Bob and also this logistic thing. So I'm thinking that if, for example, the seller submit the correct answer, and then that the thing will trigger the contract to exchange the payment, right? To transfer the
Yes,
payment,
correct.
right? My question is, how can I verify if the logistic, for example, the logistic result or submission is correct, or the answer for Sudoku is correct, and that is the desired answer, or that is something that triggers the payment to be transferred? How
Yeah,
can the machine analyze the truthfulness for that service or for that output?
yeah, that's the whole point for the smart contract, right? So-called smart contract. Basically, the smart contract in our case is to take the inputs, whatever that's the Sudoku solution or the the route in the logistic problem. They take the input and check if the input is valid. That's the whole thing, right? If you remember a few slides back, right? This is a solution. You can think about the keys here. In different smart contracts have different inputs, right? The Sudoku solution or the route, and then whatever you just talk about, how do you validate? That's what you code in the smart contract, and that's the only purpose for the smart contract. You have to. This is pretty much the condition you are saying. Hey, under what conditions can I release this fund? Can this fund be released, be redeemed? For example, in the Sudoku example would be, oh, I plug in all the missing, the entries in, and then I check whether, oh, the Sudoku is all, so the column is good, the rows are good, all the, subgrid is good, right? That's how you code it. And also maybe in the logistic, you're saying, hey, if this is a route, I'm going to take, calculate the entire length. I compare with some like a predetermined threshold. If this is under 100, let's say 100 kilometers, I'm going to have you take my money. Otherwise, you cannot take the money. So all the logic you talk about, validate, is what the smart contract does actually. Does this make
So
sense?
for the analogy, for analogy of Alice and Bob, it means that Alice will do all the if condition and if else condition so that it will validate the response.
Yes, the solution.
Okay.
Yeah, that's
Okay.
what becomes. Yeah, that's what's in the smart contract.
Thank you.
Good question.
I take it you can time out the smart contract. So if nobody solves it within a certain time.
Oh yeah. Usually,
yeah.
that's a good point. Yeah, you even mentioned in the article. Usually give us some kind of deadline, right? Because you don't want to. For example, in the worst case, right? I may give out a Sudoku example, which may not even have a solution, right? You don't want to get the money get stuck. So you want to. So in practice, usually give us some kind of deadline. If nobody solve it before this deadline, the bounty, you can take the money back.
Yeah.
Okay. So if no further question, I'm going to go to the next type of applications, which also I'm super excited about, and the so-called games, right? Games, have been on the blockchain, for a while, and up until now, these games are very simple, right? Think about, let's say, chess or CryptoKitties or whatnot, like a simple game. Is the feature is they're all transparent, meaning, because you are putting the game onto the blockchain, everybody can see everything, right? So it's like playing chess, right? I know your moves, you know mine. But this type of game usually are not, if you look at the most popular games people playing today, right? So World of Warcraft or even poker, right? It's not fully transparent, meaning, you don't know everything, right? For example, you are playing some kind of World of Warcraft, you don't know what's going on at the end of the other end of the virtual world. You don't know what other players going to do, right? That's a more fun strategy for all this kind of real-time strategic massive online games. Right? You so-called fog of war. You don't know everything. So until now, you cannot bring this type of game on blockchain because once you put the games on chain, everybody can see everything, right? But recently we discovered, I think also in some other blockchains, they discover you can use this like a very fancy cryptography called zero knowledge proof. So basically, you can enable us to do what? You can put the game, say poker, you can put the game onto the blockchain. You can verify the rules are followed, but you are not disclosing, all the information out there. So, for example, now you can finally play poker on top of Bitcoin, which is impossible before. And we have devised a few examples. One is so-called Battleship, and we designed a game called this. So, if how many of you have seen this game before? Battleship.
Yeah.
Yep.
Anybody? Okay. So that's good. So basically, this game is, you have 2 players, and how does this work? You have pretty much like a physical board. You place your fleet here, then place a fleet over there. You cannot see each other's fleet position. And then you are going to guess. You are going to fire at each coordinate. But because you cannot see, so you can only, guess, right? And then this is whoever sunk, the opponent's entire fleet first, he wins, right? So recently we just released this example by running on Bitcoin. We can use this fancy cryptography called zero knowledge proof, saying, hey, I cannot see it, but if I fire at some coordinate, let's say 5, 3, you need to give me a proof. This proof says, okay, is this a hit or miss? And with this proof, you're not giving me your location, but you cannot cheat. If it's a hit, it's a hit. It's a miss, it's a miss. You cannot cheat. So we have released even a game on Bitcoin you can play today. And also we have a fully interactive course. If you have, even you don't know anything about, if you have zero knowledge proof, you can go through this interactive course. Hopefully by the end, you can have a very grasp. You can develop your own zero knowledge games on top of Bitcoin. I think this is a very simple example, but it's as complicated as any, World of Warcraft level. This is another game called Dark Forest, and this so far running on some other Ethereum sidechain. But is this think about this almost like a World of Warcraft. So you have different planets, and each body has some planets. They're going to build the resources. They can send the soldiers to conquer, the other planet. So the whole thing about the magic about this type of game is doable actually today. It's running. It can be, it's running on other blockchains, but it actually can run on better on Bitcoin because, scalability and also fully programmable. So actually you can port this to Bitcoin, it can run today, and you can play all this kind of the most sophisticated strategic game on top of Bitcoin today. So I think Liam just at the very beginning hinting about we are doing a hackathon actually, zero knowledge. So if you know any kind of this kind of, you're interested in building so-called hidden information games, that's one big category that I strongly recommend. You go to check out our hackathon. If you can compete building some kind of games, I think this one huge potential for killer apps for not only for Bitcoin but also for blockchain in general. Anything here? I can keep going. Yeah, I think this is one of my favorite Bitcoin, oriented application out there because, once you put the games on blockchain, it's almost like infinitely extensible. For example, right? So right now, all your games live on some centralized servers, right? Blizzard, whatnot, right? But think about now, once you put the game, it's really a metaverse. Think about it, right?
Yeah.
You can, anybody, it's just Bitcoin transaction to interact with. You can build your own client. If you don't like it, you can change the whole UI if you want. It's just a protocol now. Every game is like a protocol. You can build your own client. You can use your own UI. If you don't like the, some elements, it doesn't belong to one single, let's say, gaming company. It's fully on chain. So it's fully, and also it's fully interoperable with all the on-chain data out there. Right? For example, here if you don't like, for example, you can mint your NFT, right? So if you have some planets, you can mint an NFT, and then you can instantly go to some other games and use the same NFT because it's all on blockchain. So this really is opens a new world, games.
Yeah.
That's
I suppose
impossible
you can also earn,
before.
can't you?
Yeah, you can earn. You can build
BSV
any
or pay
logic.
BSV.
Yeah. If you want to build payment into it, for example, here a Battleship, before you just play for fun, but if you just want to have a little bit of skin in the game, you can say, hey, I lock up, 1 Bitcoin before I go and join. Whoever wins, eventually they can take the 1 Bitcoin out, just earn some money, right? It's just new type of crypto applications that's only possible right now on a blockchain, on Bitcoin. So I think so far the applications we are doing is like kind of like porting the traditional games, and then add some like tokens on top of our payment, right? But this not, I would say it's crypto native, right? It's not the Bitcoin native because all the logic, all the code, every data is all still stored in some server you cannot see, right? I think this is good try, but what for me personally more excited is about, you're like everything is on Bitcoin. So it enables entirely new type of applications that's impossible before. The thing about almost like, all the technology evolution, right? Internet, then you have mobile, right? I mean, at the beginning, when first have a mobile phone, I remember like saying, hey, people are asking, why do you need to run it on your iPhone or whatever? You have a desktop machine, right? But then people develop like Angry Bird, right? Or say Instagram, right? I mean, in theory, you can take a laptop and go outside and then take pictures, upload, right? But it's not just as convenient. So same thing here. I think the crypto, this kind of games is also something that can leverage the Bitcoin technology that's impossible before, right? I mean, you can do the payments, you can do a token. I mean, it's good. It doesn't leverage the full power of Bitcoin. You see what I mean here? So this is something completely different. Once you put on the entire games on chain, you can enable all kinds of things. For example, the Dark Forest game. A lot of people, for example, they don't like the UI, right? They just fork the client that build their own UI. They can have their own plugin. Because it's truly permissionless, right? If you can use this word. Anybody who can do anything on this game, there's no company control it. So it's fully, you pretty much building that's the only way I see in the metaverse is if ever going to be adopted, that's how you probably don't want to trust Zuckerberg, Facebook to control your digital life, right? This has to be something kind of neutral and almost like a protocol. You define how characters interact with each other in the virtual world, and then you build this. Nobody has full control, right? Even let's say Facebook, bankrupt tomorrow, right? You can still play this game, but you can only put this on blockchain because otherwise you have hosted on some central server that, at the end of the day, all companies, doesn't matter how great they are today, they're going to bankrupt, right? They're going to disappear. You don't want to, if it's your digital life, you don't want to just bind this to some trusted company, which may go out anytime.
Yeah. So I don't know anything about this dark forest. It looks very complicated, but how would that sort of thing work actually then? So I presume you have a client that creates smart contracts and it would create a smart contract for your character or whatever, your profile. And then you would create different smart contracts to interact with other players. Yeah.
I think that's more like a more advanced version. I think when you talk about different contracts interact with each other, but the simplest way, think about it, you have only one master contract, right? And in this master contract, it has the global state for the game. For example, Battleship or Dark Forest, right? Battleship, this contract knows, all the information about the board, and how many moves has been going on so far, and how many spots has been hit, right? So this global state in this single contract is a so-called stateful contract, right? Every time it has a game state, single game state, which is the source of truth. And then every time you make a move, you update this game. So you just always have one instance.
Is that not scalable then? Isn't that what you were talking about in the beginning, that we could have multiple contracts Because if you just got one, surely if you've got 1 million people trying to play this game, that's the bottleneck, isn't it?
Yeah, that's one way. Okay, so to think about it, just one, you can put it into one, right? Single smart contract. That's that's
Maybe you need
easiest way. Right?
Maybe you need another chain, a sort of layer 2 chain.
Yes,
actually
I
do
think
the
if
little-
yeah, kind of like, yeah, you pretty much, that's one way, right? You speed up. Basically, everybody, let's say, have a kind of like I don't want to call it layer 2, but you can have like a sequencer or so-called relayer, coordinator, whatever.
Yeah.
You can put it there, and everybody send the move over there, and then you just aggregate all this into some transactions and then send it there, send to the blockchain. So you don't need to. So the client doesn't interact directly with the blockchain. It interacts some kind of like almost like an overlay network over there. So each game has their own overlay network. That's how
I
I
suppose
see
then
it
it's centralized,
come to
isn't
play.
it, more?
Oh, the good thing is, you can have multiple coordinators, right? Because it's at the end of the day, all the data and the logic is on chain, right? There's no, if you don't like this coordinate, you can spin up your own, almost like a miner, right? So if you don't not like this miner, you don't like what they're doing, you can spin up your own. It's an open protocol, right? You don't have to, let's say, ask Tao to join the mining, right? Hopefully, right? So, so that's one way to combat this issue, to speed up. The other way will be more advanced. I think we are still doing a lot of research into this. You can speed up by just, instead of have one single contract in one UTXO, you can split them up, right? Each player may have their own UTXO. So in that case, it is even more performant.
That's what I was thinking. That's what came to mind straight away, that you have got like thousands of UTXOs and smart contracts in one game. But of course, you need someone to keep track of them all, because they'd be changing position all the time, wouldn't they? I suppose.
Yes.
Every time.
Yes. I think because I even putting a single UTXO, I think for now it's not a bottleneck. Because remember, even you have one single UTXO, it's just the update, the chain of transactions is sequential, right? So once you broadcast all this to the miners, they don't care, right? They don't care whether this UTXO, the chain together, because they just processing. It's like you put, they can still be parallel. It's just the chain of transactions is sequential, but this is off chain, right? Once you send to miners, they don't care, right? If it's one transaction UTXO, they are not connected anywhere in the transaction graph, or if it's a chain to the miners, doesn't matter, right? It's also so in that case, is at least it's much better than any other blockchains out there. That's the bottom line, right? Because on Ethereum, for example, this game is actually quite popular, and then 1,000 people start playing at the same time, and then crash the whole chain. So that's what actually happened. So they have to move to some testnet, and then side chains, and then some other blockchains. It always happens like this. Actually, that's why, if you want to some lowest hanging fruit, you take those good ideas from other blockchains, pretty much apply it to Bitcoin, and then you can launch much smoother. And the other funny story is, because for any other blockchain, they don't have zero conf. So if you play this kind of so-called real-time strategic game, you have to wait for your transaction to be mined. So that usually takes like 20 seconds or so. So it's not really real time. But for us, we have instant transactions, right? So it's actually as if you're playing like a traditional game. So that's another big advantage. It's real time, the real time.
So I think we spoke about this before, but is the infrastructure for keeping track of these smart contracts, is that available? You must have something listening to a node and seeing where the smart contract is, which TX out point it is, I presume. Or does the client take track of that, keep track of that? Or is that not the right time to ask the question?
No, it's a very good question. I think that's I want to talk to you guys, because we at S-Script, we don't, that's like out of scope for our case. We just have the developer tools, and then how to build service on top of this. I think some people are already doing this. For example, right, BitTrails, I don't know, you heard about this, and also Mempool. So they also build some additional service saying, if you have a single stateful contract, how do I know how to query the latest, the tip of the chain, right? That's something we already, we don't do at script, but some other people, let's say Bitrails and also mempool, they're building service like this, right? So for example, if you have, let's say Battleship, you can submit this API query, right? What is the latest state, right? You can query, right? So if your Tao is interested, I think that's definitely something you can look into, because if stateful contract keep coming, and you don't want to every gamer or game companies to run their own node, right?
Exactly. Yeah. I know mempool have a touchstone thing, don't they, which keeps track of their badge contracts and the likes, which is open source. And we have something at Tile already, which is keeping track of various tokens. So we can discuss that.
Okay. Yeah. Any other thoughts here? If not, I've just can keep moving.
Yeah, sorry, I'm asking so many questions.
No, it's good. I think I keep it interactive. Instead of me just giving one directional talk, I would prefer more people to ask me. So, okay, I think this is I'm probably going to, this is the last slide I'm going to talk about today. I'm going to leave the rest to the next one, because we're already at 1 hour mark. So, and another big example is the online, machine learning models. For example, here we recently implemented this, the neural network. What this neural network does is you can recognize handwritten digits. Right? So if you write from 0, 1, 2, handwritten, and this is the input, you're going to give you the output. Hey, what's your guess on what this number is? So this is like pretty much like a hello world for deep neural networks. And we just implemented this as a smart contract. So if you have some diagram inputs to the blockchain, and then you can give it the output. So usually this is just another example of, not only is theoretically possible on Bitcoin, we have already implemented this before. So once you have this kind of machine learning primitive, you can think about all kinds of use cases, right? For example, I've talked before, right? So if you have some, let's say you don't want to train your own model, you want to outsource this to find the best model. Now the whole world is open to you, right? So you just host this competition out there to broadcast some transaction, and then whoever has the best model you are looking for, they can get paid, and then you get the best model. And then because earlier I even talked about zero knowledge, right? So the one naive way to implement this is called model. So basically think about all the ways for different connections, the different numerical values, and then you have the inputs. But because we are also implementing zero knowledge, now you can also do it even better, which is more practical for a lot of applications. For example, you can think about this as a, when you're applying for a loan, and this can be, the model to calculate your credit score, right? Your trustworthiness. So, and this is the financial data. For example, your salary, your debt, your let's say spending history, right? But in a lot of cases, you may not want to disclose this, especially now you put it on blockchain, everybody can see it, right? So you can use the zero knowledge to produce a proof. Hey, this is my data, and this is the result. Let's say credit score. Right? But at the same time, you can hide your private information. That's one use case, right? Another use case, hey, this is a model. This is like my IP, right? For example, this can be some kind of like a biomedical company. It has this sophisticated model it developed in-house, spend billions of dollars. You can, let's say this give an X-ray. It would tell you whether you have cancer or anything, right? This is proprietary. It doesn't want to disclose the information. But then you can say, hey, I can hide the model here. And if you give me the X-ray, I can give you the result very accurately, maybe 99%, right? So you can also run all this kind of primitive, you can put on the blockchain, and then because blockchain and the contract, they're fully interoperable, right? They can talk to anybody, any contract out there. So you can build this as like a primitive, for example, you can say, hey, I host this Kaggle competition, or you can say, hey, I have this on-chain loan. I can call this very good machine model to get a credit card score, or I can have this, let's say, also medical app. I can keep track whether you are healthy or not, right? I can give you a score. You can put all this kind of on blockchain. You may even think about, all kind of other extended applications. Right? You can say, hey, I have this smart contract. You say, hey, if you keep running, 5 kilometers every day, if I check you reach this, I give you, I don't know, 5 satoshis. Just incentivize people to get more healthy. Or you can say, hey, if you want to apply for this loan, you can improve you can repay all your debt or 80% of your debt, so you can be qualified for this loan, right? You can incentivize all kind of things with this kind of micro payment type of thing. So this smart contract here is to build all the logic. That's how with what I just mentioned, right? All the logic, the business logic is going to be coded in the smart contract. But then I'm just showing here is any sophisticated, previously thought impossible Bitcoin, you can do it actually today. So all the examples I just talked about, you can find it on our website. Go to script.io and you can find, we also have a blog there. You can click all the examples I talk about here. You can find the working code demonstrated, and of course coded in our language script. So that's I think I'm going to stop here and see if any concluding remarks or questions here. Anybody?
I thought that was very interesting. I'm quite excited about the game part as well.
Yeah.
So I'll certainly be looking.
That's also my personal favorite, actually, because you are doing something other than speculation. So it could be fun. And you can only do it on Bitcoin and on a blockchain. Yeah.
Yeah, I'll certainly be looking at the site and the hackathon
The games.
stuff. I think it's a bit, it's probably a bit late to join because I mean I don't have.
Oh,
the
you already no. It's lasts for a month, so you still have like 3 weeks to go. I think most people, if it's like college student, right? If you probably like 1 month before the finals, first week you are doing a little bit. Probably you're doing 90% of work at the last. That's just me.
Yeah.
Maybe it's just me. Yeah.
So I can
it's
see
not
if there's
late.
any. So I can see if there's any teams that are looking for people and with my particular skill set.
Yes, the hosting website, dev post, they also have a option to say, hey, you are looking for team members also. Or
cool.
I mean, you already have like 15 people here, so you probably want to reach out and already have find some people here too.
Yeah, if anyone's interested.
Yeah, 45,000 doesn't matter the price of BSV, so
exactly.
It's always going to be 45,000.
I have organizational question. So how many lessons will be in this course, and will be there some practical part, and if it will be, in which form it will be?
Yeah, great question. I think that's the first one. I want to just get a sense of what everybody's background coming from. And it's going to be probably at least a dozen courses coming. So to be from very like basic level, which are like today I'm not going to get hands-on, but later on we're going to because a lot of people here are developers, we're going to have a more hands-on experience. We even have some I would say almost like a homework thing. So the best case will be by the end of this, you're going to from 0 to hero. Basically, you have zero about Bitcoin smart contract. By the end, you're going to develop some not only smart contract but also how to integrate it into a consumer app. So it's going to be like around 10. That's my plan. But I'm going to gather all the feedback for after each course. I'm going to see how everybody is progressing, and then based on that also I can make an adjustment. But right now my guess is about each course is about 45 minutes, and then it's about 10, and then we're going to, once we have the basic, intermediate, and advanced, it's also going to have different level of homework or let's say demo project people can work on. Is that something you guys are looking forward to?
Yeah, okay, thanks.
Yeah, that would be interesting.
Yeah, great.
Is this for developers only?
No,
Or people
no,
with no,
no. It's like today, right?
Yeah.
So I hopefully today's talk is more high level. So even if you're not hands-on developer, you get something out of this.
Mhm. Yeah, definitely.
Okay. But that's the one thing I think I'm going to go from some kind of like easy, intermediate, and then advanced. So if you are not a developer hands-on every single day coding, you probably want to take the first 2 stages, I would say, and then the last one is going to be very hands-on. So at least anybody who can get to the comfortable level. You don't have to stay for the whole till the end, but anybody who can at least can get to the level that which they feel is comfortable.
Yeah, that makes sense.
So maybe just just a question on the curriculum. So it is recommended to start with easy and then evolve over time? Or,
Yes, that's
okay, good.
yeah. Basically, because here I'm doing the almost like common denominator, right? Because I don't want to start with advanced and then scare most of people away. I want to get it,
Wants to
to
at the
start with
difficult.
easier. Yeah.
Yeah, very well, thank you.
Also, a
question, thank
question
you.
about prerequisites that you sent us. So there was a long YouTube course and also a lot of sources on the GitHub, different courses here. So are we expected like to learn all the information from the GitHub because it's very much for us to consume now, or should like any of the courses from the GitHub be sufficient on its own?
Yeah, good question. So if you're talking about GitHub, so today we kind of almost like an encyclopedia of all the examples we developed, which is close to 100. I haven't checked it today, but it's close to 100. I agree. It's not organized. That's why we have this course. I think it's going to be more formalized. We are going to develop, put them into different categories, at least for the different difficulty level. So I think there it's good to once we are walking into the course, and then if you want to read about more about every topic, you can go there to browse. But I think it's recommended to follow this course. I think I'm going to kind of put this scattered around the courses into more organized fashion, so you can more easily navigate it. Does this make sense?
Yeah, thanks.
Okay. I think some people sending chats. Okay.
Yeah, I'm just happy that I'm not alone, being not the developer in this team.
No, it's good. It's good. We need all kinds of people. So to have different perspective, because as I said, right? If I just assume everybody already knows everything about smart contract or Bitcoin smart contract, then I probably have when I do the talk, it's going to be scary. I think hopefully you guys can calibrate and then let me know the feedback in real time so I can adjust. So more people can know about this, because to me, this is almost like a bigger secret that's in plain text. That's the plain sight out there. We are talking about all other blockchains. The SU, what's the latest year, whatever, is always coming out. But I think this is the most powerful, the most advanced tech out there. But it's just people has not realized yet. This is the the real deal out there. So we need more people to learn about it, and then hopefully they can compare it with alternative, right? So you don't have to trust whatever said here. It's always you can independently verify all these claims. So hopefully we can have more people come in and then spread the word, and then more people. It's almost like a movement, right? You want people to join. So I want to have all the learning also to be accessible to the widest audience. I don't want to just go out there and talk about the most sophisticated things, which is not going to help with adoption, I think.
That's cool. Thank you, Xiaowei.
Thank you for coming. Okay. Anything else? Closing thought? Otherwise, we can see you hopefully all in next week, the same time.
Awesome.
Okay,
Very well, thank you
great.
very much.
Okay, thank you.
Very
Thank you
much.
everybody for coming.
Thank you.
Yeah, if you have,
Thank you.
yeah, thank you. Last thing, if you have not joined our Slack, please join, because that's the place you can find me in real time. I'm happy to answer any question you have out there. That's the best way for us to communicate.
Is it some separate Slack from the towels?
Yeah, it's a separate. Go to script.io, this website, and then at the bottom there's a Slack logo. You click, you can join. It's open to everybody.
Okay.
Okay. All right. See you next time, everybody. Have a good one.
Thank you.
Thank
See you.
you.
Bye.
Very much.
Bye.
Okay.
Bye.
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 Oh, the link. Okay.